Okay, today we're going to start graphing rational functions, section 7.4. We're handing you a separate sheet with a list of things to do in order to graph these. I suggest you read that ahead of time. All right, so I'm looking at number 1 here. First thing I want to do is start to factor. So on the top here, we're going to get x plus 3, x minus 3 all over x plus 3. I see we have a common term in the numerator and denominator. What that does is create a whole. So these guys are going to cancel out. We're going to be left with x minus 3. So we got a whole with an x value of negative 3, because that's what would make that go to 0. To find the y value that goes with that, you're going to plug that back into this here. So we'd have minus 3 minus 3. The y coordinate would be negative 6. Vertical asymptotes would come from the denominator going to 0, but since that canceled out, we will have no vertical asymptote at this point. This is going to be a linear line. This is just a slope and a y-intercept. So we're no longer going to have a horizontal asymptote. The x-intercept would come from solving this equation here, letting y be 0. So the x-intercept is going to happen at 3. The y-intercept will occur when we substitute 0 in for x. So we're going to have a y-intercept at negative 3. Now normally for the slant asymptote in this section here, we're not going to have any. We'll see those in 4.2a. But normally if the numerator exponent is higher than the denominator, you're opened up to a slant asymptote. But since all that canceled out, again we have none here. Normally I'm going to require you guys to put points in there, but since this is just a linear equation, we can graph this one real easy. So I know I have a whole at negative 3, negative 6, 2. So we're going to put a whole there. We have y-intercept at negative 3, had an x at 3, and this guy's got a, oops, I missed that guy there, that's a 2, at negative 3. This guy has a slope of 1, so the line's going like this. To the whole, we pick up on the other side of the whole, and that's our graph of this particular rational function. All right, let's look at the next example. Get down a little. Okay, the first thing I noticed here is that my exponents are the same. That's going to open us up for a horizontal asymptote. But let's just see what happens when we start to factor. So the numerator factors into 3x minus 5, x minus 4. The denominator factors into x minus 4, x minus 1. These factors cancel. When we have factors that cancel, we get a whole. The x value of which is going to be, if you set that particular factor equal to 0, so we'd get 4. And what we're left with here is that equation. To get the y value, we're going to substitute in 4 into the equation. So it's going to be 3 times 4 minus 5 over 4 minus 1. And what we get is 7/3. So at 4 and 7/3, I get a whole. So 1, 2, 3, 4, 7/3 would be right about there. You just got to give us an estimate and be in between the right two integers when we get fractions like this. Vertical asymptotes come from the denominator here. What would set that equal to 0? So in this case, that would be the vertical line, x is equal to 1. We show our asymptotes with a dotted line down our graph. Since what we've got here, our exponents are the same, that means our horizontal asymptote is going to come from the leading coefficient, so it would be 3 over 1. So in this case, we're going to have a horizontal asymptote of y is equal to 3. To find our x-intercept, that comes from solving the numerator. So if I was to solve the numerator for 0, set that equal to 0, I would get 5/3. All right, so let's get these things on here. We had a horizontal asymptote at y is equal to 3. I also have an x-intercept at 5/3. That's going to be about there. Y-intercept will occur when we put 0 in for the x's. So we're going to get a y-intercept of 5. 2. Be careful on these. Sometimes when you put the asymptotes in, you want to count from there. But remember, you do need to count from the origin. If you have a horizontal asymptote, then you will not have a slant asymptote. And at this point, I'm just asking you to plug these guys into the graphing calculator. We're going to put this equation into y equals. We're going to grab some points. So, I got for the points here, negative 2, 3.7, negative 1, 4. So negative 2, 3.7 would have been here. Negative 1 was about 1, 2, 3, 4 here. The y-intercept, so I can see I've got a graph going like this, approaching that asymptote. On the other side, I just grabbed a couple of points too. You do need to list them out for us. I've got 2, 1, 3, 2, 5, 2.5. So 2, 1 would be about here. 3, 2 would be about here. That's really enough to kind of get the shape of what we're looking for. Remember, we got that hole there. We need to make sure that's clear. Okay, let's try example number 3. Scoot this page down. All right, so I'm looking at this. Again, first thing we want to do is start to factor. So I've got x minus 4 over x minus 3, x plus 2. So none of those factors cancel there, so that means this graph has no holes. Vertical asymptotes come from whatever numbers that would drive the denominator to 0. In this case, we have 2 vertical asymptotes. One's happening at x equals 3, and x is equal to negative 2. So let's get those vertical asymptotes into our graph. A horizontal asymptote, now I'm looking at the exponents here. Since the exponent in the denominator is bigger than the one in the numerator, our horizontal asymptote will be the y-axis. So it's going to be the line y is equal to 0. Again, shown with a dotted line. To find our x-intercept, that comes from the numerator, solving this numerator to 0, so we're going to get 4. And then to get our y-intercept, it comes from putting zeros in for all these x's, and what we're going to find is that we get 2/3. So I have an x-intercept of 4, and I kind of look at that, I'm like, but I got an asymptote there, so that's kind of a curious situation, right? So we're going to talk about that in a minute. I have a y-intercept at 2/3, and that's right about here. So normally with asymptotes, you can't cross them, and that's definitely true for the vertical ones. However, the horizontal asymptotes are there really just to guide end behaviors out near negative infinity all the way out here and positive infinity. So it can cross near the middle of the graph. So if your points are showing that you cross a horizontal asymptote, it is okay. So I started grabbing some points off the calculator, again putting this equation here into the y equals. So I got minus 3, negative 1.2, negative 6, negative 0.6, and I just kind of like to go in sections. So negative 6, negative 0.6 would have been about here. Negative 3 would have been about 1.2, and I can see this guy is going to scoop around this way. Then I'm looking for some points in that middle section. So I grabbed negative 1, told me it was 2.5, 0 was 0.7, but we knew that from the y-intercept. I got 1 at 0.5, 2 at 0.5. So this guy looked like kind of here, kind of straightened out, and then he starts heading up again. It's looking something like that. And then in the last section, I just grabbed 2 points over there. I grabbed 4, 0, which we knew was our x-intercept, and 5.07. So that'd be kind of right along here. What's happening? This guy is crossing and then kind of hovering near that horizontal asymptote. I did forget to fill out this section. Remember, if we have a horizontal asymptote, you cannot have a slant asymptote. All right, let's look at problem number 4. Let's graph number 4. So again, one of the first things we want to do is start to factor everything. So we could factor 3 out of the numerator. We could factor an x out of the denominator. But this piece here is still factorable. So we're going to continue to factor until we cannot factor anymore. You have the x. Again, we'll look for 2 numbers that multiply to be 12, that subtract to be 4, that's going to be 6 and 2. And what I see here is that the x plus 6 will cancel out, and when we have factors that cancel, we get a hole in the graph. So that's going to be at -6. When we put that into the graph here, so what we're left with, let's see, we're going to get 3 over, let's finish this guy out. Okay, so we're going to get 3 over, over -6 times -6 minus 2. So that's going to be 848 negative, going to be positive over 48, and I'm going to get 1/16. So -6, 1/16 is going to get me a hole. It's going to be right about over there. That's the best I can get that. Vertical asymptotes, we're going to have 2. We're going to have one at x is equal to 0 and x is equal to 2. So one's on the y-axis, the other one is on 2. Since there's no x's left here, so the exponent in the denominator is bigger, we're going to have a horizontal asymptote at y is equal to 0. We are not going to have an x-intercept. There's no x's sitting in this numerator there. For a y-intercept, because we have a vertical asymptote sitting on the y-axis, there'll be none there. Remember, asymptotes hold true for the vertical. Since we have a horizontal, we certainly cannot have a slant. And just picking a couple of extra points, I got -1, -2, -2, -1, -1, -2, -2, -1. So this guy's kind of coming around like this here. No, oops, I copied the wrong points, guys. Hold on. That was the other problem. Oh, I'm so sorry. Let's take that back. Let's get rid of what I just said there. This guy needs to be up on the top part. All right, so the wrong point. So I got x, y for the left section there. -2.375, -1, 1. So -2.375, remember we have a hole there. It's about here. -2, 1. So this guy's happening kind of like that, picking up on the other side of the hole. In the middle part, I just picked up 1 point. I was looking at the graph as well on the calculator, which you are allowed to do. We had 1, -3, and this guy's kind of going like this. And in the last section here, we have 3, 1, 4.37. So 3, 1 would be here, 4.37. This guy's kind of scooting around like that. Okay, one more to go. Let's hope I get all the right points this time. My apologies. First thing we're going to do is factor both the numerator and denominator. So that's for the numerator, that's a difference of two perfect squares. And the denominator, we're going to get x minus 5, x minus 1. The x minus 5's cancel, that's going to get us a whole with an x value of 5. We're left with x plus 5 over x minus 1. To get the y value of the whole, we're going to plug in the x value 5 both here and here. That's going to get us 10 over 4, and that would reduce to positive 5 over 2, or 2.5. Vertical asymptotes happen with the numbers that drive the denominator to 0. So in this case, we have just 1. It's going to be at x is equal to 1. Again, shown with a horizontal, the vertical dotted line. A horizontal asymptote, because the exponents are the same here, is going to be the coefficients of the two numbers in front. Well, we don't see anything. There's two 1s in front of both of those. So we're going to have a horizontal asymptote at y is equal to 1, shown with the dotted line. The x-intercept comes from solving that numerator, setting it equal to 0. So we're going to have an x-intercept at negative 5. So that will happen right there. The y-intercept happens when we put in 0 for x and for y. So we're going to get one at negative 5. So there's our y-intercept. Since we have a horizontal asymptote, you cannot have a slant asymptote. And again, we said we would introduce those in next week. At this point, we just need a couple of extra points you can grab from the table on your calculator. If you're not sure how to do that, please ask your teacher how to work the calculators. On the left side, I got negative 1, negative 2. I also got negative 2, negative 1. That's enough to kind of see the pattern this guy's taking. And again, you can peek at the calculator graph itself too. You do need to show the points that you're pulling in order to get credit for these problems. And then we have 2, 7, 4, 3. So 2, 7 be way up here off the graph a little bit. 4, 3 would be sitting kind of here. So this guy's going to be scooting in like this. Okay, time to get started on that practice, and we'll pick up at 4.4a on the next video lesson.